So today would be our Indus special day. And to begin, it would be Dr. Nisha Yadav, who is, of course, needs no introduction because she's quite famous in this area. She's along with Professor Mayank Vaya, who is also in the audience and who will be giving another talk later today. She, along with Rajesh Rao, Ronojoy, and so on, have done seminal work on looking at statistical analysis of the Indus inscriptions, and she'll be mentioning a bit of this work in this talk. Before I invite her to the stage, a few announcements. So I very much hope that all of you have given your TA form because, to be very frank, if we receive anything after now, I don't think our office will be able to process it. So I hope every one of you have given your TA forms. And second, if you have not already signed up for the Tiger Cave excursion, please do so, because tomorrow being the institute being officially closed, actually we have to tell the bus what capacity seat bus we need today itself. So so please do, if you have changed your mind about going to the excursion, please do let us know. Okay, and thirdly, there is a small change in the schedule. So if you and I made those changes in the web page as well as in the paper schedule that is posted outside the hall. So one is there's a slight change in the title of Professor Rahul Siddharthan's talk, which is immediately after Dr. Nisha Yadav's talk. So Rahul would be actually talking a bit on how actually one builds phylogenetic trees for languages. How do you make language families? Because this is something that we kind of discussed after one of the talks, and Rahul felt that this might be a good thing to include in one of the talks he's giving. Secondly, I have invoked my privilege as the faculty member to arm twist Ashraf into giving some of his time to me. So Ashraf will be giving the last talk on this finding direction of a sequence using statistical methods. So I essentially asked him if I could take a little bit of his time. So I'll be going first and finishing the talk that I was giving yesterday on Shannon, Markov Shannon Ziff, statistical analysis of inscriptions. So I had talked about the Markovian part, but not so much about the Shannon part and the Ziff part. So I will be talking about the concluding part of my talk, and then Ashraf will follow it up with his work, with description of his work, which actually will be using many of the concepts I'll be introducing in the talk today, basically information entropy. All right. So with those few announcements, let me invite now Dr. Nisha Yadav of the Tata Institute of Fundamental Research to speak about unraveling the structure of the Indus script, a computational perspective.
Good morning, everyone. At the outset, I would first like to thank the organizers of this workshop, Professor Sita Brasina and Dr. Ashraf, for inviting me to this workshop and for their very kind hospitality. We at TIFR began a computational study of the Indus script somewhere in the year 2006, and in my talk today, I'm going to highlight some of the major results of our study so far on the subject. But before I go into the details of our computational studies, I would like to provide you a brief overview of the material on which the texts are inscribed. So, let us start a discussion by taking a look at what Colin Renfrew has to say on writing. Colin Renfrew says in his book Archaeology and Language, the practice of writing and the development of a coherent system of science, a script, is something which is seen only in complex societies. Writing, in other words, is a feature of civilizations. We all know that the Indus Valley civilization was unique, and indeed it was very complex too. There are several aspects that that intrigue scholars all over the world about this civilization, but one of its most intriguing aspects is its script that has defied decipherment. Now, taking a look at the map of the old world, we find that the Indus Valley civilization was one of the largest of the 4 major Bronze Age civilizations. The others, namely Egyptian, Mesopotamian, and Chinese, which was contemporary to the Indus Valley civilization. It spanned an area of about more than 1.5 million square kilometers, that is covering almost the whole of the entire Pakistan, the current day Pakistan, northwestern parts of India, as well as some parts of Afghanistan. Now, what about the writing system? The Chinese script continues even today, so it never went out of scene, so there was never a question of decipherment. But both ancient Egyptian hieroglyphs as well as the Mesopotamian cuneiform texts that had once become obsolete because people no longer used them could later be deciphered with the help of bilingual inscriptions. We have not been that lucky in the case of Indus Valley civilization, and hence its writing that often appears on these kind of small seals continues to puzzle scholars all over the world. Now, taking a look at the beginning of this culture, the roots of this civilization go back to about 7000 BC, where at the sites such as Mehergarh and several other sites, we find early signs of this culture coming up. But at this stage, we do not find any evidence of writing. In the next phase, that is the Ravi phase, which spans from 3200 BC to 2800 BC, we find precursors of the Indus script in the form of post-firing graffiti and pre-firing watermarks. Now, these markings become more formalized in the next phase. And here, if you take a closer look, we'll realize that we can even identify some of the signs which made their way to the sign list of the Indus script. For example, this sign is the sign number 347 in the sign list of Mahadevan. Not only signs, but even sign sequences seem to be present on these markings from this co-Digean phase, that is just before the mature phase of the culture, which span from 2800 BC to 2500 BC. These are the texts from the mature phase which were inscribed on the Indus seals, and we can see that this sequence makes its appearance on several of these seals. So, these numbers?
Yeah.
Oh, okay. These are the numbers by which the signs are identified. So, in the sign list, I'll be coming to that in more detail. So, each sign is given a number. Okay. So, we have, when we work on this computational lesson, we have to encode everything in terms of numbers. So, the sign number 1, for example, a stick like human figure is given sign number 1 and so on. All right.
Thank you.
Okay, so the seals and sealing are the account for majority of the writing. That is about 80% of the Indus writing appears on this kind of square and rectangular seals and sealing. We often find evidence of writing on other kind of objects, which include miniature tablets, which account for about 10% of the writing, the copper tablets, which account for another 5%, even on pottery, as pottery graffiti, ivory sticks, even stoneware, bangles, and so on. We find impression of the seals on the clay tags which are found from Lothal. And there is one exception to this, the writing appearing on a larger object, and that was from the site of Dholavira. So we know that from the site of Dholavira, a signboard was discovered, and there it is a 3 meter long signboard, but even on that we find just 10 signs, and it can be seen as an enlarged version of this bar seal basically. So now if we take a closer look at the square seal, so these are the string of signs which form an Indus text. Generally we have an animal in a square seal. The most often depicted animal is the unicorn, but we do find evidence of other animals such as elephant, tiger, bull, etc. on other seals. And in case of unicorn, there is a very interesting and enigmatic object. There are several theories even about this object, but we'll not go into those details. But in case of other animals, generally a feeding trough is present instead of this enigmatic manger. So this rectangular seal is actually interesting. It is as if someone has deliberately twisted it to safeguard the information from being copied on other surfaces. Copper tablets have the style of their own. Instead of having the writing and the animal with this feeding trough on one side, we have writing on one side and the animal and this feeding trough on the other side. So the presence of writing on these various different kinds of objects does suggest that the script was quite versatile and would have encoded a variety of messages. Okay, now taking a closer look at some of the components of the Indus seals. Now, in square Indus seal, we generally find the Indus text, the animal motif, and this manger. But often on several other seals, we do find evidence of other components which are listed over here, which include narrative scenes, human figures, plant motifs, composite animals, multi-headed animals, and so on. Though the individual contribution of each of these components is not much in the inscribed corpus, it is these components that tell us something about the ideology of Indus people. So let us take a quick look at some of these components. Okay, so for example, this is a seal where you can see a series of 7 figures standing side by side. There is a jar-shaped object over here, maybe a tree, because you can see the leaves over here. There is a standing horn-shaped figure over here. There is a seated figure as if offering something to the person, the figure in this jar. And there are some Indus signs scattered on the right side, top right of this seal. Then we have an example of a composite animal over here. If we just take a closer look at these components of this composite animal, we find that it seems to have the face of a human being, the horns of a water buffalo, the trunk of an elephant, the front part of the body of a bovine, the rear part of a tiger, and so on. Clearly, it is an artist's attempt to put together the significant features of various different animals or into one figure, and this seems to be one such attempt. This is this interesting, very small cylindrical seal, and if we just roll it over a sheet of clay, this is what comes out. So this kind of narrative scene could be easily depicted on a long sheet of clay, but someone was experimenting by carving it on a cylindrical seal so that the same thing can be copied again and again over different objects. So we can see a figure standing in the middle, 2 other figures side by side, and there are 2 script characters also can be seen in here. And this is again a composite of a human and an animal, and one more figure over here. This is a bar seal, and 2 sides of this bar seal are shown over here. So here in the center we have the Indus script characters. This is again a human figure, a person with a jar as if offering something to the tree over here. This is an abstract pattern over here. Again, here we can see a scene, a man fighting with 2 other persons, a person fighting with 2 other persons, each holding an uprooted tree. There is another seated figure in this tree, and an animal is watching this person, and so on. So looking at some more pattern, this is the famous seal which is referred to as the Pashupati seal. But you can see this figure seem to have 3 heads, at least it can be seen over here. And some animals are flanking this figure. There is an Indus text at the top. The person is seated on a stool, and there are some animals below that. Then this is an example of an abstract pattern with heads of different animals conjoined together. And there is a script which is actually missing because this was a broken object. Then this is another seal where this pattern was depicted on different sides. So there is a scene, a person fighting with the bull, another seated person over here. We can see a person fighting with 2 animals. This is an Indus sign and an elephant below. So this is an example of a multi-headed animal, and you can see a script sign here. This is again a composite of a human and an animal, and the two script sign can be seen over here. Now these are some of the examples of geometric and abstract patterns. Generally, they are not associated with script, but they are interesting in their own way. You can see this. We have several examples of this swastika symbol on this inscribed objects. Several such seals have been found from the site of Mohenjo-daro. Actually, different forms of this swastika can be seen over there. It seems to have four-fold symmetry. This pattern seems to have five-fold symmetry. This is an interesting seal. Now, this seems to have a mirror symmetry. You can see if you just take it into half, the two sides look identical, mirror of each other basically. And it is also interesting for one more thing, that here you can find the script or the text at the bottom of the seal. So in all of these cases, you may have realized the size of the object doesn't go beyond few centimeter by few centimeter. But even on these small objects with a wide variety of patterns, the Indus people managed to convey a lot. So these inscribed objects are best described by the following words of Wheeler. He says, at the very best, it would be no exaggeration to describe them as little masterpieces of controlled realism, with a monumental strength in one sense out of all proportion to their size, and in another entirely related to it. So, with these words of Wheeler, let us shift our focus on what did they write. We are trying to figure this out. But let us take a look at this question, and that is, why did ancient people write in the first place? Writing allowed people to store records, that is for accounting purposes, keep a track of time, to facilitate communication over short and long distances, even for religious purposes. So for ancient hieroglyphs were mostly used for religious purposes, and even at times to express superiority and power. But the ambiguity associated with the context and usage of Indus signs has made the problem of Indus script even more challenging. And what adds to the challenge are the following things. The Indus texts are very short and brief. The average number of signs on an Indus seal is just 5. The longest single line text contains 14 signs, and the longest text, which is a 3-side, this is actually a prism-shaped object having the text on 3 sides, it consists of 26 signs. Secondly, we do not have any information about the spoken language or languages. Finally, lack of bilingual or multilingual objects adds to the problem of decipherment. But this has now deterred scholars to try to read the Indus script. And there have been numerous attempts. Researchers from various disciplines have been attempting to read the Indus script with no clear answer. The two major schools of thoughts are that one school thinks that this concourse or Dravidian, Proto-Dravidian language. Another school thinks that it encoded probably an Indo-European language. A group of scholars even said that it is not a script at all. And some people even try to associate it completely with numbers. But the bottom line is, the sign system of the Indus culture remains ambiguous, with contested claims of decipherment, but no consensus on any of them. So we decided to start afresh. We make no assumptions about the nature, content, or purpose of the Indus script. Our first attempt was to write in the Indus script rather than read it. So we use computational tools and techniques that can probe specific aspects of various types of data. The objective of our study was to identify the structure and nature of a collection of written material, especially when the background knowledge is not enough. And finally, the present approach can be used to identify the syntactic framework of the Indus script, which can be used to evaluate various claims of decipherment. So, before I start on computation studies discussion about that, I would just quickly like to cover two important aspects about the script, and that is one is the sign list, and secondly this direction. So the sign list of the Indus scripts looks something like this. So we have been using Mahadevan's corpus for for analysis, and this is 1/4 of the sign list. So there are about 417 signs in the sign list, and so 4 such panels actually make the complete sign list. Now you can notice over here that each sign is identified by a number. So we have a series of signs which look like stick-like human figures. So sign number 1 to 48, for example, look like stick human figures and so on, various forms of that. Then we have a series of signs which where we can identify some shape which looks like fish, then some birds and something like that. And we also have a series of signs which are look numerical, but they may have some other function in the script as well. Notice that some signs seem to be a compound of other simple signs. So 2 such examples are highlighted over here. So for example, this seems to be a compound of these two. Now these 2 signs seem to differ just by the presence of a hat on this fish. So I'll be going into these the details of the sign design in the later part of my talk, but for the time being, just keep these things in your mind. Now, there is some relation between the number of signs and script type, and the presentations before have actually covered some aspects of these, but I would just like to just cover it a bit. So, see, there are 4 major types of script based on the number of signs in the sign list, and they are logographic, logosyllabic, syllabic, and alphabetic. So in logographic script, each sign is a complete word. So there are word signs. There are about thousands of signs in this kind of scripts, and Chinese is an example of that. On the other hand, we have logosyllabic scripts where the word it consists of word signs as well as phonetic syllables. There are about 400 to 900 signs in this kind of scripts, and examples are Sumerian, Egyptian, and so on. Then we have syllabic writing. So where we have closed and open syllables, and the count of signs is 100 to 200 in case of closed this category, and for this it is 40 to 100. And these are some of these scripts which fall into this category. Then we have the alphabetic script. We have single sound signs, which number of characters doesn't go beyond 40 in most cases, and these are the examples of some of these. Now, by the count of signs, Indus seem to fall in this category, logosyllabic, and this kind of system generally used various kind of techniques such as rebus principle, which where an abstract concept is conveyed using pictures, where pictures are used for their phonetic value rather than their pictorial value. An example was already shown. For example, how we can write a word such as belief, which is an abstract concept, which has put a picture of bee and a leaf, and here both bee and leaf are used for their phonetic value rather than their pictorial value. And whether the pictorial value was to be used or the phonetic value was actually either marked in the text or it was to be understood from the context. So, secondly, let us come to this aspect of the script, that is, what about its direction? Now, suppose I give you a piece of small piece of paper and with a line, and I'll ask you to fit a text sentence on that. And you start normally, and suddenly you realize at the end, oh God, I'm left with very little space. What you'll do? Exactly. So, this seems to be happening over here. For example, you will see cramping of size towards the left end of the object. So, the script you can see starts normally, but because there was very little space left over here, this last character and few other characters seems to have been squeezed on the left end. So, this suggests right to left direction. Again, we have overflow of the characters from the first line to the next. So, this is an example of that. So, this is a very frequent text ender sign, and because there was no space, the sign is written in the next second line. Then we have this kind of example where the text starts normally, and then it is the signs are tilted and
Ma'am, but how do we decide that it's not a contiguous word rather than it has been just squeezed or something of that sort, rather than it being a separate line?
those signs are actually present in the sign list. They're not joined. It's not that you mean to say it's a compound word?
Yeah.
It's not compound. So clearly, I mean, there is space in between. If this image may not be like showing you, but actually, if you can look at the photographs from CSI, etc., you can see that those are different.
Also for the second image,
And this is just one example. There are several such examples.
okay, this one makes sense. But for the second one, isn't there a possibility that that's another line or some other word?
It can be. That is true. See, there are multi-line text. I mean, but what considerations we have to keep in mind is that, see, we have to see. Like I told you, this is only one such instance. Okay, and we have to take into consideration the correlation between these two signs. For example, so if there is a very high correlation of these two things coming in the text again and again, that increases the probability in the favor of the chance that it maybe should have been placed here.
Okay, thank you.
Okay.
Yeah.
Okay, so we have this kind of gap at the right end, and this again shows the right to left direction. So all these are like external features through which archaeologists have tried to say that it seems to have right to left direction. There was even a study by Professor B.B. Lal, I think, where he used the method of overlapping incisions to arrive at the same conclusion. So all this is indicative of right to left direction, though there are a few exceptions too. So let us now start with our computational studies of the Indus script. So given a set of data, what is the first analysis you will do? Exactly. Yeah. So first of all, you should have an idea about the sign list. If you have a sign list already, you know the different signs. Then the next, what will do?
Variations between signs.
It's directly. Okay, sign variance you mean? Okay. See, that process is already done. You have a corpus, you have a concordance, and it is the texts are encoded based on that. So what is the first piece of analysis you would like to do? Correct. So you like to first of all count and see how is the frequency distribution. So this is how the various size of the sign list, the frequency distribution of the size in this sign list of Mahadevan is like. So you can see just 67 signs out of 417 signs account for about 80% of the writing. The most frequent sign is this jar-shaped sign, the sign number 342, which is not only the most frequent, but it also occurs at the ending position of the text, end position, the text as a text ender. So we can easily fit the Zipf-Mandelbrot law to this sign frequency distribution. And second, then moving ahead, if we just now browse through the text, okay, and see, just look for patterns. What do we notice? I mean, actually here it's highlighted over here, but we notice that there are certain signs which seem to appear at the beginning of the Indus text, and actually I've listed the texts which have this sign, but there are other beginners also, and there are a set of signs which often make their appearance on the at the end of the Indus text. It is not that we never find this sign at the center, but it is most favorite location is at the end. Okay, so we can quantify this this pattern of usage of this text enders and text beginners using the computational frequency distribution plot, and it is shown over here. So given a sequence S1 to S5, where S1 stands for the beginner and beginner, and S5 stands for the ender. What is this plot telling you? Yeah, that while we need about 80 signs to account for 80% of all text beginners. See, the blue curve is for the text beginners and the green curve is for the text enders. So while we require 80 signs to account for 80% of all text beginners, we just need 20 signs to account for 80% of all text enders. So what is this telling you about the pattern of usage of text beginners and text enders? Clearly, there is an asymmetry in the usage of text enders and text beginners, right? Given a sign at the beginner position, will you have more flexibility to use different signs at this location or at this location? This place, right? So there are more ways we can open a text, but very limited number of ways we can end a text, right? So the beginner and ender asymmetry provides clues about the direction. That certainly these sides are important, whether it is the first position or the ender position, as well as some clues about the presence of structure. But so far, we have been just worrying about single signs. Okay? What about correlation between signs? Whether there exists correlation between signs? Yes.
Okay, is this analysis based on the fact that the writing is from right to left?
It is not.
It is not. Okay, so how do we know that?
See, it is just a marker. I mean, we have just when we refer to something, we have to say either you can have to use right side or left side, right? But it is not what the results are not going to change if you that is your question.
But why is that? Because we are considering the right as the beginning of the text and the left end as the ending of the text. So that is how the analysis is based, right? Like the beginning is on the right and the ending is on the left.
No, see in that case, if you are saying in that view, if you find so what will happen in that case? If you're saying this S1, if you just think that for a moment that okay, this is the ender and this is the beginner, then instead of S1 having more, the text beginner will be more restrictive and the text ender will be more. But as I'll show you in the analysis, I mean, while this thing, the results, I mean, you just have to flip the naming convention rather than anything else. We will discuss if you want.
Ma'am, in this graph we have for test beginners and enders. So are we considering one particular sign that is appearing over the various scripts for, text beginning or ending, or it's like a collective analysis that is happening here?
You collect, you take all the text, you take all the text beginners you collect all the text beginners together and you see how many of these beginners account for 80% of all the text beginners, okay? Similarly, you take all the text enders and you do make the cumulative frequency distribution plot of that, and then you arrive at that number and then you compare.
Okay, thank you.
Okay, so in order to address the question of correlation between signs, the first question we wanted to answer was, are Indus texts just a collection of randomly ordered signs or is there any sequencing? So what we did was we just shuffled the signs in the Indus text and checked how often we get similar sequence by chance in this randomized corpus and compared it against the real Indus data. So what comes out of this study is the following. We found that the sign sequences of size 2, 3 or 4 signs, that is, there were certain pairs, triplets and quadruplets that were appearing far more frequently in the original Indus dataset than what can expect by chance. The immediate question was, okay, if this kind of significant pairs, triplets and quadruplets do appear, frequent pairs, where are they actually distributed in the text? So that brought to us the second piece of analysis, and that was positional distribution of these frequent sign sequences. We did this for pairs, triplets as well as quadruplets. I'm just showing you for the pairs. So if you just take a look at these, the most frequent pair in the Indus text, that is the 267, the diamond-shaped sign followed by the two-stroke sign. So this is the most frequent pair, and 85% of times it starts in Indus text. Similarly, this pair has a favorite location in the middle of the text. So about 90% of times it appears in the middle of the text. And this sign pair most often ends the text. So this trend was not only true for the pairs, it was also true for the frequent triplets and quadruplets. So they seem to have a preferred location in the Indus text. Okay, so these are the numbers that actually were given over here for all the 4 positions for different frequent pairs. I think some 10 of them are listed over here. So this, for example, in the data almost often, appear only at the beginning. Could be a, in the data which we considered, it was the case. If you find another instance in our text, maybe in future this may change.
So far,
But so far, its preferred location will certainly not change, because in the yeah. Okay. So see, I told you at the beginning that this length of the Indus text varies from 1 to 14 size, right? So when we were going through the text, we found that these we identified the text beginners. The size which appear often in the beginner, or the terminal size. Okay, to be more beginner, and instead of saying that, they were making their appearance in the somewhere in the middle of the text. So we wanted to find out whether why is it happening, whether we can segment in this longer text in some way. Are there 2 or 3 different pieces of information joined together, strung together? That is something which we wanted to check. So this we can perform the segmentation in different ways. So we can just for example, compare the shorter and longer text occurring from on different objects. So this is, for example, a very long text, and this is the object identifier. This is this 4-string number, this 4-digit number, sorry. And then the components of this longer text appear on 3 other objects. So actually, if you consider they are complete text, you can segment it in this way. Now, we can also consider frequent sign sequences as meaningful units of information, and we can use them as well to segment the text. We can also, another way of segmenting is, if we have a long string, you just keep on finding the weaker and stronger junctions. Okay, so if a pair of sign appears often, if those two signs have a high amount of affinity, that is a strong junction. And if a pair of signs appear very rarely, you can consider it a weaker junction, and you can break it over here. So we actually devised a segmentation scheme which took into consideration of all these different aspects, and we segmented the entire corpus. And these are some of the examples shown over here. About 90% of the texts of size 5 or more could be actually segmented using this scheme. And the examples are, you just ignore this marker. This was just used to identify the segments. But no, we used all this the techniques which I showed you. So in the segmentation scheme actually incorporated all the 3 in that. So see, once we have a segmented corpus, just as an interesting exercise, I already showed you the most of these natural languages follows the Zipf's law, and we have seen that in the earlier talks and all that stuff. But I just wanted to compute the Zipf's exponent for the segmented corpus. So see, this is if we just consider the tokens as signs, then this is what we get as a Zipf's exponent. For English Brown corpus, you can see it is almost 1. If you reduce the size of the corpus, okay, and make it, this was just something I wanted to check. If we just reduce the number of words, so it falls a bit. So for the Indus script, if you consider each sign as a word, in that case, this is the Zipf's exponent. But if you segment the corpus, and here each segment is the unit, basically. What that segment stands for, we have no clue at the present stage. If it's a language, it could be syllable, or part of or a word or something like that. It is a meaningful unit of information for the time being. So if we just run the Zipf's analysis over that, this is what we get as a Zipf's exponent. Alright, so after this, we resorted to the current day machine learning techniques to build a computational model of the Indus script. So research in machine learning and data mining has led to new techniques for developing statistical model of sequences. These techniques are quite generic. They are used for analyzing various types of sequences of words, sequences of characters, sequences of amino acids, which is the protein, ATGC sequences, that is DNA sequences, and so on. Even musical notes. These models are not sensitive to the semantic content of the sequences, but reveal the syntax, if any, that the sequences follow. The models can be used for pattern recognition and pattern completion, and we created a statistical model of the Indus script. So I'll just give a brief overview of the models which we used. Actually, these are I used n-grams and Markov models. So these are probabilistic models which provide a very useful method of modeling different types of sequences. This is okay. See, the order of the Markov model, as Professor Rahul already mentioned in his talk, decides the length of the correlation. So the corpus of the Indus script was modeled with with varying n. So with n-grams starting from 1 to n equal to 5, where n defines the length of the correlation. If n is 1, it is bigram correlation, the first order, and so on. So we found that the perplexity, this is a measure of how good a model is, reduced considerably when bigram correlations were taken into account, and there was not much change after that. So we study the bigram model of the Indus script in most of our analysis. So just to give you, for those who you don't have a background about this, I would like to just first of all tell you how we do it for English, and then I'll go for the Indus, because it will be much easier to understand. So here I have not included the space, so I just kept 26 for, yeah.
I accept the data and the small corpus size we have. Is it possible to even go beyond the bigram model?
No, we use this smoothing techniques, and we could actually build trigram. I mean, we did till trigram, I think we could do. Yeah. So in our paper, this Pilos paper, we have those statistics available.
Which smoothing technique did you use?
Written well.
Thanks.
Okay. So the state space consists of 26 letters of the alphabet. So you can see over here. So these are three main parameters of the model. The state space that is shown over here. The transition matrix, which like Professor Sitabra was actually talking about yesterday. So this is the transition matrix which tells you with what probability each letter which will be followed by another. The size of the matrix here is 26 by 26, and this is the initial probability, state probability vector, which tells you with what probability this letter will start a text, and so on. So what kind of insights can we get from this model for English? So at the level of individual word, with each letter as an independent token, we find that if we build a bigram model of English, the letter T can be succeeded by a lot of letters such as A, E, O, but not X or Z. Similarly, the letter Q is most often succeeded by U, and so on. Now, if we consider instead of letters, words as the tokens, if we build a similar model using words as tokens, what kind of insights can we get? So we find that if the tokens are words, then the word there can be succeeded by a large number of words, but not verbs such as eat, the, eat. We don't say the, eat, right? So we just now map just replace those letters using this Indus signs. Okay, so Indus texts were mapped to sequence of states, and the model of the Indus script, you can see just replace those ABC by the signs, and these were the three main parameters of the bigram model for the Indus script. And this was the bigram matrix of the Indus script. Now, once we have this model, we can use for several interesting applications. So first of all, we tried to see whether we were getting the same empirical observations which we made from the data in other ways, whether these were coming out from this model. A. Yes. Actually, I was expecting that. The sign number 342 has association with a lot of other signs. So that is actually shown over here. There are two lines you can see, and there is in this sign number 99 that also has a similar affinity of size with a large number of signs. So that is, those two things are shown over there. Yeah, we can also use this model to fill in damaged or illegible Indus text. We can all see in the corpus. Actually, sometimes the person who was creating the corpus could not identify the sign, but he reads the sign and puts some kind of marking. We can actually confirm whether the reading was correct using this model, and I'll show you how we can go about that. We can even analyze variation in writing from different regions by using likelihood studies, and we can generate Indus-like text from as based on this model. Okay, so these are the initial observations which I already showed you. I'll quickly go over this. See, I already showed you these are the three main text beginners. Okay, if you just see that, okay, just give us the most often which sign often comes at the beginning. These three signs actually stand out. Similarly, we can make this query for the text enders. Then we can even find information about the affinity between signs. So if we say that, okay, given this sign, with which sign it appears most often, so we can actually plot that conditional probability graph over here, and you can see that clearly it has a favorite sign. This is sign number 99. So similarly, we can see with other beginners also, these were the favorite signs with which they appear. Now, enders, on the other hand, do not have this kind of preferences, I mean, except this 211. So you can see 342 seems to have friendship with all the other signs, but I mean, there is no favorite in that case. And similarly, we have other. So the initial observations were actually confirmed by this model. And we also find that there are signs, and there seem to be signs in the corpus which seem to have specific syntactic function. For example, this is the beginner, this is the ender, then they have correlations between them and so on. Now, how do we go about restoring the Indus text? So this is an example of an object which is broken and the text is lost. So we can use this model to fill in these signs. Now, how do we go about it? So, see, in Mahadevan's corpus, there are texts such as these, where on some of the sides at times there is an asterisk mark. So this is a doubtful reading. So he kept it in the corpus, but he said that these are doubtful. So we can use our model to confirm whether the reading was correct or not. And then similar way, we can use the model to even restore the text. Okay, so instead of so what we exactly do? So if we have this kind of size, we just drop it off, okay, from the text, and then ask our model to fill in for these blank spaces. Okay, so we found that in most of the cases the reading was correct, but the model also provided us with some options. Okay, this is the most probability restoration, but the next most probability restoration is this, and so on. So the model was able to restore the damaged text with about 75% accuracy. Now, we also did an interesting exercise. We said, okay, what if we don't give anything to the model? We'll ask the model, just give us the most probable 4 sign text. We just gave 4 blank spaces with the initial and the initial, just the beginner and the text. So these were the predicted text by the model. Okay, so you see that in case of text of length 4 and text of length 5, we could find an identical match in the corpus. These were the texts which were identical to this. But in case of 6, we didn't find an identical match. This 1, 2, 3, 4, 5, 6. We found a match which was having 2 signs interspersed in that. But the overall pattern was that. Okay, these were some more texts which were generated from the model. So, okay. Now, like I said, at times we find Indus seals and at various space station sites. Now, this seal is particularly interesting, but because not only for its shape, we do not generally find circular seals, but the seals generally which were found in Persian Gulf and that side are circular, and we have some writing on them. The script is clearly Indus. So, we can do likelihood studies based on our model for these kind of West Station texts coming from the seals which were discovered at West Station sites. So, this is the seal we are talking about. So, this is a West impression of a round stamp seal from West Asia. The sequence 342, the sign number 342 followed by itself, never occurs in the Indus corpus of about 4,000 texts from the Harappan sites. But we found an instance of that in the West Station site. So, how we can do a likelihood study? How can we? Okay, yeah. So, using a model, we can compute the likelihood of this text. So, just for an example, before we take an original case, this is an Indus text. The likelihood of this Indus text is computed as this. So, if we just alter the sequence, it almost drops to 0. Now, we just plug in the Indus seal as a text which we find from typical Indus region, that is maybe from Harappa or Mohenjo-daro. So, the likelihood of that text is of the order of this. If we now plug in this text, you can see the likelihood is very low. So, West Asia seal is approximately 100,000 times unlikely to be generated by the learned model of the Indus text. Okay. Now, we also did some study to compare the correlation of size in the Indus script with various linguistic and non-linguistic systems, and I'll just like to quickly cover this too. In general, given a piece of text, the order of size in a written text can be random, where the order is not important. It could be rigid, very rigid, that is, the ordering is very precise and determined. Given a sign, only one particular sign can follow or precede that thing. Or it can be somewhere in between. So flexible, that is when there exists a degree of freedom in choosing the order to allow expression of a variety of information. So we compared the conditional entropy of Indus sign system with various linguistic and non-linguistic systems. Now, conditional entropy actually quantifies the amount of flexibility in choosing a sign given a preceding sign. So, this is the plot of the result of a study. So, the various data sets which were used in the study are shown over here. For Indus, we had the Mahadevan corpus. For English, we used the Brown corpus. We also had data for Sanskrit, the Rigvedic text, Old Tamil, Ethiopia text, Sumerian, Oxford corpus, DNA, for that we used human genome, protein, E. coli, and Fortran. We had a Fortran code. Okay, so the conditional entropy on the y-axis and the number of tokens on the x-axis. So you can see there are two controls also shown over here. One on the top is standing for the random. There is extreme amount of flexibility. The one at the bottom is very rigid. Okay, now you can see the Indus sits in this band, which is mostly taken up by the linguistic systems. The computer language is Fortran. That curve was somewhere here, and DNA and the music, etc. But here they're not shown actually in this. So far, so we looked at various aspects of the script using various different computational techniques. We built a model of the Indus script. We saw how we can use this model to check the variation in writing, to restore the text, and so on. So, in the next piece of analysis, we use the unsupervised machine learning techniques to cluster the Indus text. So, I'll just quickly cover this result in this next 2 slides. So, the associations between the signs in the Indus text were explored using clustering and unsupervised machine learning technique. Now, 9 clusters of Indus text were extracted using this study, and it was found that the signs in these clusters were more similar to each other. The text in each cluster were more similar to each other than with the text correspond from a different cluster. So, these are the importance, the frequent sequences of these clusters are shown over here. Clearly, you can see there are signs and sign groups which seem to have an affinity to a particular cluster. So, this sign, for example, seems to be having an affinity to cluster 2. This ender seems to be having affinity to cluster 3, and so on. The immediate question was, do these clusters have any association to the type of object or the site of discovery? The answer was unfortunately no. The 9 clusters were found to have their signature set of sign and sign sequences. The text clusters were not found to have any significant correlation to the sites of discovery or object types. And the study suggested that the Indus writing had clusters of text corresponding to distinct style or content. This is what we can conclude from this
Nisha, so are these clusters clusters of sequences?
text. So basically we take the entire corpus and we say we use this unsupervised machine learning algorithm. We say just divide this entire corpus divide it based on the usage of science in them. So based on that, it just gives us this cluster.
In the structure of the signs, or where the
usage of science?
Usage as in where in the text it is from?
Yeah, it actually depends on the which clustering you are actually using. So you must have known about the document clustering and various other things. Have you actually use these techniques very often in clustering documents and text and so on in natural language processing. So this technique was used for the Indus text.
All right.
Okay, so so far we so this is just a framework to understand the Indus script. Okay, a comprehensive framework to understand the Indus. So far we have focused mostly on the structural studies. That is, we worried about the sign frequencies, sign sequencing. We did some amount of text restoration. I'll be covering this is coming. But we have been focusing ourselves on these aspects of this script. But the script doesn't appear in isolation. It is generally associated with a lot of context, okay? And the context comes from the site of discovery, from the type of objects, with what site of components it is associated with, and so on, okay? So we did some studies in each of these cases, some very initial studies, and I would just quickly like to cover bits and pieces of some of these. Okay, so like I said, I've already shown you the various types of objects on which the script has been found, and these are the various different sites from which the text has been, the scribe material has been excavated from. So mostly it comes from Harappa and Mohenjo-daro, but the other sites which actually account for the data are also shown over here, marked over here. Dholavira, recently Rakhigarhi, but Rakhigarhi data is very recent. I mean, it still needs to be included in that. So we use some of these clustering techniques to compare the usage of signs with different sites or different object types. Okay, so what in a piece of analysis, what we did was the following. Okay, so one of the characteristic of writing is localized variations based on specific needs of maybe a region or maybe a context. So we use hierarchical clustering to compare the usage of signs across various object types as well as different sites. So it is a method of cluster analysis, again, a unsupervised machine learning technique, which seeks to build a hierarchy of clusters. Now, variation in the usage of signs on distinct types of objects and sites was studied. And these were the results. So this is where we compare the usage of signs at various sites. So on the x-axis, we have the different sites which are marked. MD stands for Mohenjo-daro, HP for Harappa, and so on. And the distance, the sign usage, the distance is marked on the y-axis. You can see that Mohenjo-daro and Lothal texts seem to have the similar pattern of sign usage. West Asian sites, interestingly, they come out. As we saw in the earlier study also, they have a distinct usage pattern. Harappan seals, again, was close to the Kalibangan, for example. It is also located, I mean, proximity-wise also, Harappa is close to Kalibangan. Okay, and here also you can see it closer to that. So these kind of interesting insights can be obtained from this study. Similarly, if we take a look at the object types, here I've already showed you the evolution of how the scripts seem to have arisen. So here you can see in this plot the seals and pottery graffiti. Okay, they seem to have a similar sign usage. Sealings and miniature tablets were having affinity to each other. This IB is very bold. This is very scarce. I mean, you can just ignore this. So the copper tablets, on the other hand, it was located close to the seals and pottery graffiti and so on. So yeah. No. See, the thing is, in the data set, there are very, very rare cases where you actually find a copy of the seal in the data set. I mean, if you have a seal, you don't find a sealing. If you have a sealing, you don't find a corresponding seal. So actually, there's a very interesting question. I mean, why this is happening? See, on the tags, certainly we find impressions of certain things, but this is something which is very intriguing.
No, but what does that imply? You know, so the fact that, you know, clearly seals and sealings being reverse of each other, they should have some similarity. So the fact that this isn't captured here, what does it imply about?
It can imply the following, that in the data set, we have not yet discovered the corresponding either the seal or the sealing of the seal or sealing, basically. If we have a seal, the corresponding sealing may have not been discovered yet. I mean, it may come in future course of excavations, but till now we don't. I mean, the sample of data which we are working with doesn't seem to have that. Yeah, sure.
So Harappa on the left side, it's an outlier compared to, and
true.
It's supposed to Harappa as the mature civilization.
Yeah,
right?
but there are certain variations which in the sign usage pattern. If you go to my I think it is in 2013. There is it's actually this result is also listed over is present over there. So there in detail I have shown the sign usage pattern at various different sites. So Harappa seems to have certain certain signs which were used more often, and they were not being used that often in Mohenjo-daro, and so on. So that was really very interesting. I mean, so I can tell you offhand the signs which are used very often at Harappa.
But in terms of time period, is Harappa different?
No, no. Well, see, See, Harappa sequence we can actually match. Mohenjo-daro generally is more of the mature phase. Okay, I mean most of the data comes from the mature phase. Harappa, Harappan, the harp excavations which have recently taken place in 1980s or so. So from there we find data coming from 3200 BC and so on. But most of the data certainly comes from the mature phase of the Harappa.
There are a few symbols there in the Edakal caves of Wayanad, similar to the Harappan symbols. Okay. Yeah, I think it's also considered along with the Kalibangan and Chandidar.
I haven't looked at it. If you can show me.
It's identified and published.
On the caves, you are saying, right?
In the Edakal
I think I read a few news articles about that, but I couldn't see the published.
Okay.
Yeah, so this is in connection with what Rahul was saying. Actually, that raises a very intriguing possibility See, the earliest excavations of Mohenjo-daro, Mackay was the first one to do stratigraphy. And so, whereas for Harappa, no stratigraphy was done. They just put together everything that was found in across different layers. So it could be, as Rahul is saying, that the reason for this dissimilarity is because we are comparing across different eras in Harappa and Mohenjo-daro, right? Because we don't have the stratigraphic data for Harappa until the HARP project came.
Well, see, these issues are there, but for the stratigraphy was very well maintained in the HARP data, which was done by Kanoyer et al. So there we have data which has, the stratigraphy very intact. The excavations were carried out in a very systematic way. So we do have actually stratigraphical information. Yeah. See, broadly you will not see the sign which is, for example, 342 is dominant over Harappa also and this also. These are certain intricacies which you find out. For example, I have a very see, what is the expected frequency given this size of corpus from this site, okay? And when you do that kind of analysis for these different sites, there are certain signs which stand out in both these cases, and those are actually listed. I didn't show it over here, but those are present over. Okay, now I think this is the last piece of analysis. So we looked at the design of Indus signs. So I told you, so this is the sign, 1/4 of the sign list I already showed you, and there are these kind of observations that some signs seem to be a combination of different signs. Some signs seem to be modified by little modifiers here and there. Then some signs seem to be composite of and also modified by these modifiers and so on. So when we were looking at this scanning through this sign list, we realized that there seem to be certain design elements, and let us try to see, in case of at least these compounds, whether these compounds are some sort of shorthanding or something else was going on. So the first thing which we had to do for this was to identify the design elements. So we identified 3 categories. Okay, just to give you a brief overview, the designs have various levels of complexity. So we first identified the design elements and decomposed the composite size based on these design elements, and we then studied the usage pattern of compound size and the decomposed composites or compounds. So if we have a sign which seems to be a combination of A and B, 2 independent signs in the sign list. So if there is a composite, say C, which is equal to A plus B, we want to see whether C is equal to AB or BC, and so on. In any combination, can you replace this composite with these components or not? So these were the design elements which were identified based on visually. So we identified 154 basic signs, which were the most simple form of the signs which we could identify in the sign list. There were certain provisional basic signs. So these signs which were listed in this provisional category did not have an independent occurrence in the sign list, but they were making it their appearance very often in the design of several other Indus signs. So this, for example, did not occur as a sign in the sign list, but it occurs as a component of different signs in the sign list and so on. Then we also have this inverted this is another thing. So then we identified 21 modifiers. So these are examples of 2 modifiers which are shown over here. So okay. So these are the 4 different strokes. You can see on 20 signs you can find these strokes. Okay, they're making its appearance. This is a pointed hat, and then there are these signs where this modifier seems to be making its appearance. So based on this, then we go back to the sign list and we just say, okay, there are 2 broad categories, basic signs and composite signs. Then we using these design elements, we can have 2 different categories, compound signs, which are simple additives of this basic size, and the modified signs where apart from having 2 or more different size, they also are modified with some sort of these modifiers which were identified. So we then did study of the compound signs where we try to look for the usage pattern of the compound sign and see if in any of the cases, instead of those compound signs, their sub-components are being used in any combination. So, for example, if we have this sign, we just break it like this, and we will have two combinations of this or this, and we'll say, okay, do we find a text in which this is replaced by these, and rest whatever is before and after remains same. So we carried out this exercise for almost all the compound signs, and we found that in most of the cases, the constituent elements in any combination and the composite signs do not share identical environment. The compound signs are not merely a compacted version of the possible size sequences created for brevity. They seem to have some other function in the Indus text. So to summarize, the script has a rich syntax and an underlying logic in its structure. There is a significant asymmetry in the usage of text beginners and text enders. Machine learning techniques enable us to identify syntactically valid writing and restore damaged Indus text. The script may have been used for writing West-Asian content. So, I already showed you an example. So, if you just use English to write French, we'll end up with sequences which will not make sense in English, but they are sensible in French and so on. And the flexibility of sign usage in Indus text falls within the range of linguistic systems. The signs of Indus text are intricate, and the sign compounding seem to add value to basic signs rather than save writing space. The text can be optimally subdivided into 9 distinct clusters using unsupervised machine learning techniques, and the results provide significant constraints to any model of decipherment and can be used to evaluate the same. Thank you very much. These are some of our studies which are published, and these are the various, I think some of them are listed over here. So, thank you.
Questions, comments?
So what's the general feeling on, is everything that is needed already discovered, or is still open to debate?
I don't think we have completed the study. Like I said,
I meant in the number of signs that are there, out there so far, you think whatever is out there?
I don't think so. See, with more data coming in from different sides, the sign list may expand a bit, but not to a great extent, because, for example, I think in the most recent excavations, if the sign count may have gone up, maybe by 10s or 20s, I mean, not more than that.
Thanks.
The excavation report of Keeladi, they are showing like symbols similar to Indus sign 225, 307, 365, 318, 318. And I can show you this. It's in the excavation.
Okay, I'll take a look at it.
Yeah.
Thank you.
So, the machine learning algorithms that have been used here, the paper is from 2010 and 2013, right? So, has there been any changes in the algorithms that have been developed specifically for maybe computational linguistics?
See, of course, you have a lot of choice in which algorithm you want to choose and I mean do the studies. But for I mean the results. See, we did this analysis on Indus Mahadevan's data set, okay? But recently in one of the conferences, I've seen, I mean, the same bigram analysis was being performed by somebody, either some graduate student or somebody, I don't know from where, but using Brian's data, okay? So results were identical in the sense that the restoration algorithm, he actually used the entire, even the smoothing technique was same, okay? See how it has been replicated and the results stand. That is actually something which corroborates our work, okay? I think Ashraf et al., they have done this random comparison with random text using different method. They've also used the segmentation. But the bottom line is they do not change the result, okay? And that is something which is important.
So, without more data coming in, we can't do much on the analysis front.
Well, I don't think we have completed the analysis. There are a lot of scope of work in various realms of this. Even in structural studies, I think we can use the current day techniques to explore more. Presently, I am actually involved in something very different at my workplace. So, but yeah, I'm trying to figure out, take ahead this work in a way.
Thank you, ma'am.
Thank you so much for this wonderful talk. So, I was wondering, you said that you have also tried the trigram analysis, right?
Yes.
So, the result that you found these clusters and no correlations whatsoever between
Well,
these.
those were two different pieces of study. I think you are combining. This was, I mean, we created a bigram model. We also created a trigram model, and I showed you the perplexity and all this stuff. This clustering type was different. So these are two different studies. Yeah.
Okay, so I may have confused that. Sorry. So, but so what does this actually tell? I mean, these no correlations between these clusters. So,
Yeah. So see, that means it can be related to the context of the writing. Okay, so different it can be different style of writing, or it can be, see, if you use this the script to write a very specialized content, the sign usage in that thing will differ from something you use to write something else. So say, for example, numeric thing versus the names, or I mean the different things you can think of. Okay, so it can be related to the context or the content of the writing, or it could be the style of the author. I mean, what the person or the people are trying to say, or it can also be if these texts are from very specialized category, for example, miniature tablets, and we find several replicas of their miniature tablets, and with the same engraving, and we can see which sign is being dominates in that, and so on.
thank you so much.
Thank you for the presentation. I wanted to ask something about that a specific seal. There was this one seal where there were 7 figures underneath a tree and the DT one. I mean, through computational techniques or any kind of model, so can we decipher what are those 7 figures?
Well, we can always improve on the visual aspect of that thing, but what are those? You mean to say we have to compare it against something? I mean, I didn't get your question. What are those?
What could be those 7 figures? I mean,
see, it could be as we look at that, it could be something related to their belief systems. I mean, they certainly seem to have some features, for example, horns, etc.
That's one.
It could be related to their stories or ideologies. Okay, so that kind of information actually comes out from those kind of patterns which we found there, the narrative scenes, these mythical figures, why they were joining these different animals, why there is a one-horned unicorn. People have even speculated about the unicorn. I mean, some people say it's a side view of an object. Some people say it's a mythical figure. I mean, so but then these things do provide a peep into their minds or ideology, like how their belief systems were, and so on. So yeah, we can if we have something to compare it against with, then certainly we can use some of the image recognition techniques and how we can improve the figure to compare and contrast with what we see. If we have some conjecture, we can test it against that. Yeah.
It is. I mean, it is quite interesting because in some of the, I mean, in today's culture, or even in early historic or early medieval period, there are this 7 matrikas figure.
Yes.
So I mean, it's still in usage today. So it's quite interesting to see.
Actually, I mean, a lot of theories that have been floating about even analyzing what is actually depicted on these seals. I didn't go into the details of all that thing, but yeah, there is a lot of literature available. You can read about that.
Yeah. Thank you.
Just to make a comment with respect to what you just said. So actually there is a Mesopotamian seal which also shows this 7 siege-like figures, and that's actually connected with the Epic of Gilgamesh. So it could be some legend which is there in Mesopotamia also. Sorry? Absolutely, yeah. This is Gilgamesh.
Yes.
Not identified, but generally.
Yeah, the animals are. Yeah.
I have a question about the writing style of this. There are certain seals in which we find one whole line, and in the second part we find only one symbol. So what your take on that? Why it is there only? Is it as a like a mint mark or coin on coin we find to identify certain place or something? Or
See, the one which I showed you for the direction, that seems to be just because there was a lack of space. The sign is there, but see, we did not even use that assumption in our study. We removed those kind of multi-line tests. We just wanted to keep the text which were coming from the single line text and so on. But of course, whether there was a relation between these lines in the multi-lined text on the inscription surfaces. So one way we can test it is using these statistical methods, just to see whether the sign which is at the which is just preceding that and that the sign which is just below that, they have any stronger connection, stronger frequency of occurrence as, together as a pair. So that is one way you can go about it, so it just like how or study the context of appearance of those texts across the in the entire data set actually. So you can look at which signs are following, whether it is likely for the for any text to be started using using that sign. But if it is just a single sign, see, there are examples in this corpus where there are only single signs. Okay, so there certainly that sign was meaning something. But if it is associated with the text before that and after that, there is a small probability that they may be connected. Okay, the information may be connected, it may be independent pieces of information listed over there, or it could be the same thing means there is a continuation. So both probabilities are there.
follow-up question to that, like we are basically finding patterns in this script, the nature of the script, how it works. What is your take like on this, that how plausible this will be as an argument to infer it is a very good spoken about the language of Indus script? How plausible it will be when we are saying that there is a rich and kind of rigid syntactical structure seems to be there on the available data.
See, in the absence of background information about this text, we can actually just based our conclusions on what comes out from the analysis. But we should also keep in mind several other factors. So see, there is linearity, there is directionality, there is presence of sequences, which subsequences which make their appearance very often at various different places in the entire corpus. There seem to be sign modifiers which seem to be modifying the sign. Okay, and plus there are correlation between the signs. If we just take all these things into consideration, and the fact that when we did this flexibility study of the sign against various linguistic and non-linguistic systems, it seems to present evidence in favor of the hypothesis that it could be linguistic. Okay, so in absence of any in the case of there's so much ambiguity, but we can look at this problem in a way that we have some prior information. We try to increase the evidence in favor of, or in given a new piece of analysis, whether the result increases the probability in favor of this thing being linguistic or not, in a Bayesian way, basically. So the things which we gathered till now, for example, the flexibility study, etc., tilts the evidence in favor of the linguistic hypothesis. That is what currently the state.
Thank you so much.
Anirudh?
You have most shown the correlations for bigrams, right? But let's say you have one symbol over here or one bigram over one part of the text, and let's say it has a long range correlation with something else. Do you see that? Or in the long range correlations?
I have worked on that. I'm doing some study. Actually, even in the clustering studies, it captures those kind of things. The one where I show the 9 clusters, the long range correlation that taken into account. But here I did not present those things.
Okay.